What's up, everybody? This is Mr. Tui, creator of the TSI Crash Course series available on YouTube. And if you're looking for help with the TSIA2 Math Test, you're in the right place. The College Board, makers of the test, have recently released a TSIA2 Math Practice Test. And in this video, we're going to go over some questions from that test. If you like my answer explanations and the way I approach the questions, then you're going to love the full course. Just click the link in the description here of this video. Get access to the full course. It includes over 13 hours of the best TSI math instruction available anywhere, and it's totally updated to prepare you for the TSIA2 math test. And in the meantime, enjoy the video.
Part 2. This is the TSIA2 update. We're chewing through some questions on the most recently released TSIA2 Math Practice Test. There's some graphing questions we need to go over, and this is a little bit new here. They kind of get real specific about slope. So we're going to talk about slope and y equals mx plus b form here on this question. Francisco, go ahead and read it for us loud and proud, and we'll work this one out together.
In the xy plane, the slope of the line y equals mx minus 4 is less than the slope of the line y equals x minus 4. Which of the following must be true about m?
Okay. Now this is, Francisco, this is a tough question. This is a tough question. All right? You got to really understand y equals mx plus b form to answer this question. Okay? Now, if you understand that, you can figure it out. It's really no problem at all. But you got to have a handle on y equals mx plus b form. How familiar are you with y equals mx plus b form?
It's been a while.
It's been a while. Okay, it's probably been a while for a lot of students. Let's start at the beginning. I do have a section of this on the rules for TSI Math. I don't think I had to update this too much. Let me see if we can find it. There we go, graphing. I do have this. Go to section B real quick. Go to section B. Or basic concept B, I should say. On the rules for TSI Math. And go ahead and read that first bullet point. Basic concept B, graphing. Read that first bullet point for me.
Right. For y equals mx plus b, m is the slope, rise over run. B is the y-intercept.
Okay, let me make that really, really clear. Okay, let's go back to the whiteboard. And so here's y equals mx plus b form. You need to be familiar with it here, certainly for this question, but it's helpful on some others. So y equals mx plus b form, the m value, that's the slope of the line. And slope is generally described as rise over run. Rise over run. So that is basically how much the line goes up. That's the rise. And then the run is how much it goes over. Okay? So like, let me make it concrete. I'm going to give you a little graph of a line. There's a little XY axis. And I'm going to make the line, let's make it here. Boop, boop. Make a little y-intercept right there. And I'm going to make the slope 2. Okay. So so if it goes through the y-axis here at this point, that's the y-intercept. I'll explain that in more detail in just a moment. But if the slope is 2, that would be a rise of 2 and a run of 1. So you're going up 2 over 1. So I'm going to count up from the y-intercept. 1, 2, and then over 1 right here. Here's the next point. Let me make it really clear. I've gone up 2, whoop, and over 1. That's your rise and your run. Slope of 2. You got 2 points. You got a line. Whoop, there's a line right there. With a slope of 2. I did not go through the... there, yeah, that's better. Now I went through the right point. Just as a side note there, again, the y-intercept there would be 1 because it goes through the y-axis. Here's the y-axis. Here's the x-axis. Goes through the y-axis at the point 1. The y value would be 1. How familiar is that, Francisco?
Yeah,
somewhat familiar. Somewhere in the back of your mind, somewhere in some Algebra 1 class, you've learned all this. Again, you don't even have to be able to graph lines on the TSI. Most of the graphing questions I've seen, just for your reference, most of the graphing questions I've seen, you can solve by just plugging values. It's really easy to figure out. And here, you don't even have to you don't have to graph this line. You just have to know what things mean. You just have to know that the m value is the slope. That's all you have to know. You don't even have to know it means rise over run. You just have to know the m value is the slope. That's it. Okay, let's talk about that b value while we're at it. I don't want to forget about that because there could be some questions where they test you on the y-intercept. In fact, that's coming up here in just a minute. The b value is the y-intercept, which means where the line goes through. Intercept. Here we go. Where the line goes through the y-axis. in this case, in the case of the graph I just drew, it goes to the y-axis at that point 1. That's the y value. So the y-intercept of the b value is 1. So the equation for this line that I just drew, this would be y equals 2x plus 1, because it has a slope of 2 and a y-intercept of 1. Does that make some sense, Francisco?
Yes.
Okay. Let's go back to the question here, because we're trying to find which of the following must be true about m. And is it clear now that m, the m value in y equals mx plus b form, is the slope? Is that clear?
Yes.
All right, you've got to associate the m value with slope. So they're saying what must be true about the m value? M is either equal to -1, or it equals 1, or it's less than 1, that's answer choice C, or m is greater than 1, that's answer choice D. And we got to figure out what's true about it. Does the question make sense?
Yes, I got it.
Okay. Now notice in the question they say the slope of the line y equals mx minus 4 is less than the slope of the line y equals x minus 4. I want to focus in on this equation right here. Okay, and here's my question. It's not obvious, but what is the slope of the line y equals x minus 4? What's the slope? Now you might be like, but there's no m value there. Is that kind of what you're thinking?
Yeah, that's kind of what I'm thinking, yeah.
Right? It's tricky. There is an m value, it's just kind of hidden.
If I were to make a guess, I'd probably say like maybe 1/1.
Yeah. Why do you say that? You're right. Why? Why do you know the slope is 1 for the line y equals x minus 4? Why do you know that?
I mean, usually like whenever there's like invisible, like number sign or like symbol, like it's always gonna be 1. So
yeah. So let's go back to the equation. Y equals x minus 4. Let me zoom out just a little bit. So I want to focus on that equation. Y equals x minus 4. That is the same as this equation. Y equals 1x, or 1 times x minus 4. Same thing. It's the same thing. X is the same as 1 times x. So there's sort of an implied 1 in front of the x right up here. It's implied. Does that make sense?
Yes.
What are you confused about? Anything?
No.
Okay. That's the connection you have to make to answer this question. You've got to recognize that the slope of this line right here, y equals x minus 4, the slope is 1. But is that clear now, that the slope there is 1?
Yeah, I got you.
Okay. I mean, if you wanted to graph that, you could. You could test values for x and y. I don't know, it could be complicated. I think it's just easier just to think like, okay, you know what y equals mx plus b form means. All right, the number in front of the x is the slope, and the number at the end, is the y-intercept. And here you just have to make the conscious recognition that the number in front of the x is a 1. It's an implied 1. Okay, so the slope is 1. Okay. So let's go back to the question, right, which is that the slope of this line, y equals mx... Oh, no, did not mean to do that. The slope of this line, y equals mx minus 4, the slope of that line is less than the slope of the other line, and the slope of the other line is 1. So what's the right answer? Which of the following must be true about m?
B.
Well, hold on. I think you're answering another question. You're answering the question of what's the slope of this line right here, but that's not the question. The question is what must be true about m? And m is this line, or on that line. Do you see the difference there? They're not saying what's the slope of the second line. They're asking about the slope of the first line.
Okay.
Does that make sense?
I'd say probably C.
It's C. Now, it's a little bit trickier because look at answer choice A. A could be true. I mean, M might be -1 because we know the key is the slope of the first line is less than the slope of the second line. They tell us that in the question. So M could be -1, it could be -2, it could be -3, it could be 1/2, it could be maybe 0, I don't know. It could be -1,000,000, I don't know. It could be -1, maybe. But we know for sure, no matter what, it's got to be less than 1. M is less than 1. Remember, those of you that are unfamiliar with the inequality signs, right? Remember turn this guy into a Pac-Man. Remember this from like day 1. Turn that to a Pac-Man. So Pac-Man wants to eat the bigger number, right? So there, M is less than 1 because Pac-Man's facing the bigger number. And we know M has to be less than 1 because they say in the question the slope of that line is less than the slope of the other line, and the slope of the other line is 1. Does that make sense, Francisco?
Yes.
Woo! You got to know y equals mx plus b form. You got to know what it means. Go to read question number 17 for us, please, as soon as you see it on the screen.
In the xy plane, what is the y-intercept of the graph of the equation? Y equals 6, parentheses x minus 1/2 times x plus 3.
Okay. What is the y-intercept of the graph? Okay. This is a tough question, or a tough looking question. Okay. Especially because the equation's not in y equals mx plus b form. You know what I'm saying? Clearly. It's just not. Super messy. It looks really, really complicated. Until you realize something very important. You have this very, very important concept understood. I want to go to the basic concept cheat sheet. I want to go to basic concept B, graphing. And I want you to read the second bullet point there for basic concept B. Go ahead and read that loud and proud, please.
All right. At the y-intercept, the x value is always 0.
I want you to stop and I want you to think about that for just a moment. Okay. At the y-intercept, the x value is always 0. Please understand that. Please understand that. It's essential for this question. I'm going to explain that in more detail here. Let's go back to the whiteboard. And that concept is that at the y-intercept, the x value is always 0. So let's go back to that line that I drew previously. The line that was y equals 2x plus 1. All right. Do you see that line, Francisco, on the whiteboard? Is that clear?
That's it.
Okay. So remember, that was the line y equals 2x plus 1. And you could just, if it's in y equals mx plus b form like this line is, then you can just look at the b value and be like, oh, it's 1, so the y-intercept is 1, clearly. Okay. Or you could look at the graph and be like, oh, the y value is 1 right there. It is, right? Because that's the point 0, 1 right here, where the line intersects the y-axis. But notice that x value. Notice the x value there is 0 at the y-intercept. I got news for you, Francisco. The x value is always 0 at the y-intercept. It makes so much sense if you just look at a graph of any line that goes through the y-axis. Here's another line. Okay, that's like a y-intercept of -2. But that point right there is still 0, -2. Pick any line. Doesn't matter what line it is. Another line right there. Another y-intercept. That's like a y-intercept of 4. But that's still the point 0, 4. The y-intercept, the x value at the y-intercept is always 0, no matter what. It has to be the case. Does that concept make sense, Francisco?
Yes.
Okay. So notice in this question, they're asking, what's the y-intercept of the graph of this equation? Okay. Looks really complicated. You can't put it in y equals x plus b form. You can't. But if you make the conscious recognition that you need to make, that the x value is always 0 at the y-intercept, this is really, really easy. Because all you got to do is plug in what value for x here?
Literally 0.
Plug in a 0 for x, and whatever the y is, that's the y-intercept. That's it. Does that concept make sense?
Yeah, I got you.
And it even works on you could be a parabola. Get rid of all the lines here, which I'm eventually doing. It could be a weird shaped parabola. That goes like, woo, right? Well, there's still a y-intercept, and there at that y-intercept, the x value is still 0. So it doesn't matter. It could be a weird squiggly going like, woo, all over there. It doesn't matter right there. At that y-intercept, the x value is also 0. So it doesn't matter. If they're asking about the y-intercept, just plug in a 0 for x. You'll find out what the y-intercept is. Does that make sense?
Yes.
Let's do it. Go ahead and plug that in. Let me see you work it out.
Okay. Maybe 0, and 1. 6. So we distributed next, right?
So I'm a little bit. Hold on, just a minute. What's happening? What is this right here? Hold on. What's happening here? I'm just trying to clarify. What is that?
That's just the x for 0.
That's what?
Like 0. That's just like.
You're setting the x term as 0.
Yeah.
Oh, okay. I was confused. Do you mind if I get rid of that because that's just kind of visually confusing?
Yeah.
Okay. I wasn't quite sure what was going on there. If you want to, yeah. I mean, I can. Here, let me make that really clear. I'll set x equals 0. There we go. That's probably how I would do it. But I would include the y, right? Because y equals.
Yeah.
There you go. Okay. 6 times 0 minus 1/2 times 0 plus 3. Okay, great. Let's PEMDAS this. Let's calculate what's inside the parentheses. We'll start there. It was 0 minus 1/2.
Yeah, 1/2 or negative 1/2. Yeah.
Negative 1/2. Looking good.
And then 0 plus 3 is just
3. Yeah, great.
Yeah.
What do you want to do now? You could use the calculator if you want to. Turn this if you're worried about operations with fractions, or you could probably use common sense here to figure out what 6 times negative 1/2 is.
Yeah, that's negative 3.
Negative 3, absolutely. Again, I mean, set that up. Use the calculator. Negative 1/2 is negative 0.5. It's the same thing. You got access to a calculator here. Just however you're comfortable solving that.
So yeah, that's negative 9.
Negative 9. Oh, look at that. There you go. Answer choice A. And I think this other question here requires us to have a handle on some of these terms in the glossary. Yes. Question number 19. Go and read question 19 for us, please.
For which of the following values of x is the function f of x equals the square root of 4 minus x squared not defined as a real number?
Ooh, there's a lot going on here. Okay. First of all, functions. Do you remember how to deal with functions? We covered those, I think, in day 4 of the course and probably a little more in day 5. But you're familiar with functions?
I think functions it's also been a while.
Yeah. I mean, let me go over. I'll go over it real quick again. Those that need a little refresher. But I do cover them to some extent in, I think, pretty well in day 4. So I'm just going to give you a function. I'm going to make one up. F of x equals 2x plus 1. Just keep it simple. If I said find f of 3, do you know what that means?
It's just a fancy word for x equals.
Yeah, x equals 3. Yeah, just plug in a 3 for x. That's it. Where there was an x, now there's a 3 in the function. So f of 3 is 2 times 3 plus 1. You could say f of 3 equals 7. Or you could say when your input is 3, your output is 7 in the function. That's all. Does that make some sense?
Yeah, I got it.
Same thing here. Okay. So we've got 4 possible values for x, and the answer choices, we're just going to plug those into the function. That's it. Now, we're looking for the one that is not defined as a real number. Ooh, this is really like a definition question. Okay. We got to know what this term real number means. Okay? That term real number. Do you know what a real number is?
Yeah, like like a whole number, right?
Well, it doesn't have to be a whole number. In fact, let's go to the rules. I've got this in the glossary. Okay. This one's a little tricky to wrap your head around. I'm going to explain it in detail here so you understand that. Go ahead and go to the glossary on the rules for TSI Math. Last bullet point there in the glossary. Go ahead and read that bullet point for me, please.
Any positive or negative number can include whole numbers, decimals, or fractions. Examples include 1, 15.82, negative 0.1, and 3/4.
Basically, any number, man. Any number you can think of, basically, is a real number. Essentially. Any number you can think of. It can be decimal, it can be a fraction, it can be positive, it can be negative, it can be anything. Anything. All right? Except one special kind of number that's not a real number. Go ahead and read the rest.
Okay. The only numbers that are not real numbers are negative square roots, such as square root of -4 or square root of -36. That's because there is no real solution to the square root of -4. There is no number times itself, which gives you -4.
Yeah. Yeah. I want to go back to the whiteboard real quick. And let me explain this. I want you to really understand why that's the case. Okay? Let's talk. Let me give you an example of a square root here. The square root of 16. What's the square root of 16?
Square root of 16, that's 4?
That's 4, yeah. Because what this means is, it means there's some number times itself, which gives you 16. That's what the square root sign means. There's some number times itself that gives you 16. Okay? And that number is 4. The square root of 9, it means there's some number times itself that gives you 9. And that number is 3. Right? That's kind of how square roots work. But let's back it up. What if I said, what's the square root of -16? You might be like, -4? No. -4 times -4 is actually 16. Not -16. I mean, you can try all day long. Give it a whirl. See what happens. Try to find some number times itself that gives you -16. You can't. You can't. Because if that number is positive, a positive number times a positive number is going to be positive. But even if the number is negative, a negative number times a negative number is also positive. So there's no way to get a number times itself which gives you a negative number. There's no way. So if you see something negative inside a square root sign, like a -16 or -9 or -4 or negative anything, that's not a real number. It's called an imaginary number. I don't want to get stuck on that. It's so complicated. I've tried to understand exactly. I know there's some use for them. I don't know what it is. I don't know. You can get into some like really wacky math theory that I don't want. I'm just not going to get into. But does that make sense why there's no such thing as a negative square root?
Yes.
Okay. That's funky, right? That's funky.
Yeah.
So basically, this question is a fancy way of saying what answer choice gives you a negative number inside the square root sign. If they're wondering which one is not defined as a real number. So 3 of the answer choices will give us a real number. That is something positive inside the square root sign. But one of them is going to give us a negative number inside the square root sign. And we just got to find that one. Does that make sense?
Yes.
Okay. Let me plug these in. I'm going to plug these in on the whiteboard. And I just need your help to kind of work these out. So here's the function. It's f of x equals the square root of 4 minus x squared. That's the function. Okay? So we're going to test the answers. I want to test answer choice A. So we're going to find f of -2. Okay. Okay. Let me see you plug that in, actually. I want to see you do this. Let's see. If we get a positive number inside the square root sign, we can keep it as an answer choice. But if we get a negative number inside the square root sign, we're going to get rid of it.
So -2 squared, that's -2. That's, yeah, square root of 4 minus 4.
Okay, now hold on. I'm going to clarify this for everybody watching the recording here. So all that is under... Oh, hold on. Do you mind if I'm just going to write this a little bit bigger?
Yeah, sure.
Okay. All right. So we've got inside the square root sign, we've got 4. Now you did -4. Yes, because it's PEMDAS here. We got to do the exponents first. And what's -2 squared?
That's +4.
Positive 4. Absolutely. So that's 4 minus positive 4. What's 4 minus 4?
0.
0. So that gives us the square root of 0. Interesting. What's the square root of 0?
Is it 0?
It's 0. Yeah, because 0 times 0 is 0, right? So that's real. There is a, there is a square root of 0. It's 0. Right? Does that make sense? Because the question with the square root, again, there's some number times stuff that gives you 0, and that number is 0. So we do have a real number when x is negative 2. Okay. So I'd get rid of answer choice A, because we're looking for the one that is not defined as a real number. Okay. All right, answer choice A is gone. Let's plug in the others. Woo. And again, with functions, you're just replacing the x with, a value. It's really just a fancy plug in your values question. All right, so we're going to plug in 0 now. So f of 0, testing answer choice B, equals the square root of 4 minus 0, parentheses, squared. What does that equal, Francisco?
Small 0 squared, that's a 0.
Yeah, 0 squared is 0.
So yeah, 4 minus 0.
4 minus 0.
Yeah,
So f of 0 equals... And so what's 4 minus 0?
4.
Yeah, 4 minus 0 is 4. So that's just the square root of 4.
And that's 2.
Yeah, which is 2. So is that a real number?
Yeah, that is.
Yeah, it's a real number, right? We don't have a negative inside the square root sign. That's it. That's all they're asking us. All right. So B is gone. Let's do it again. Clear some space. And, okay, so we're plugging in a 2 for x now. We'll find f of 2. F of 2 equals square root of 4 minus, parentheses, 2 squared. All that is under the square root sign. Make that really clear. Okay, so what does that equal?
2 squared, that's 4. So 4 minus 4?
4 minus 4, absolutely. 4 minus 4
0.
is 0.
0.
Square root of 0, right? We've already done that. Square root of 0 is just 0. So, yeah, f of 2 equals 0. That's a real number. So C's gone. It's looking like D, but let's confirm it. If we get a negative inside that square root sign, we know it's D. So let's do it. So we'll find f of 4. Woo. And that is the square root of 4 minus, in parentheses, 4 squared, all inside the square root sign. So what does that equal?
So 4 squared, that's 16.
That's 16, so it's going to be 4 minus 16. I want to make this really clear for anybody watching the recording. That negative sign is outside of the parentheses. So you're squaring the 4. You're not squaring negative 4. If you were squaring negative 4 times negative 4 is positive 16 here. But because that subtraction, that minus sign is outside the parentheses, you're only squaring the 4, not squaring negative 4 here. So it's still 4 minus 16. Does that make sense, Francisco?
Yes.
Okay. So that's 4 minus 16. What's 4 minus 16?
Negative 12.
Negative 12. So that's the square root of negative 12. Uh-oh. What's the square root of negative 12, Francisco?
It's like a bunch of decimals.
I mean, I don't know. Did you plug in your calculator? I don't know what you would get. You might get an error. Ah, I got an error. I got error. Because there ain't no such number. Ain't no number. There's no number times itself that gives you negative 12. Not a real number. So the answer is D.
What's up, everybody? This is Mr. Tui again. I hope you enjoyed those answer explanations from that most recently released TSIA2 Math Practice Test. Again, if you like my answer explanations, you're going to want to click on the link in the description of this video. Get access to the full course. Nobody else prepares you better for this test. Countless students are passing this test after taking TSI Math Crash Course. You can be one of them too.